Okay, my screen is visible?
Yes, sir, visible.
Okay, fine.
Yes, sir.
See, this one, this is the experiment, 4 probe, okay? See, first of all, this one is the simulation link. By clicking which you have to perform the experiment, just click this one, okay? These are the apparatus required, okay, for this experiment. Okay, see, this one is, but this is the constant current source as it is written. Then this is the voltmeter, okay, to find from here we have to find out the probe voltage, okay, and this one is known as oven, okay, and this is a temperature sensor which is already inserted inside the oven, okay, and just see the, then we have to complete the experiment. First of all, you have to write aim of the experiment. For aim of the experiment, you have to find out, you see attached file 01.pdf, okay, probe 01.pdf, okay. This is a to determine the resistivity and energy band gap of germanium by probe method, okay. That means for a germanium semiconductor, we are going to find out the energy band gap, okay. See, observation and calculations. At the time of noting observations, you have to keep current constant at 8 milliampere. Okay. Then distance between the probes is given S as 0.2 centimeter, and thickness of the sample, that means thickness of the semiconductor, is W as 0.05 centimeter. And from the standard table, we have already find out F of W by S is 5.89. Okay, and K is this 8.6 into 10 minus 5 volt by K. You see, and here we have two tables. This is table 1, and in this table, by changing the temperature with interval of 10 degrees Celsius, you have to note down the voltage in millivolt. Okay, and this voltage is called probe voltage. Okay, then after getting this observations up to 170 degrees Celsius, then after observation part is over, then you need to change the temperature to Kelvin by adding 273 with each. Okay, then table 1 over, then go to table 2. In table 2, you have to convert the Kelvin values in this T inverse, that means 1 by T into 10 to the power 3. You need to find out for each. Okay, then you have to find out rho naught. Rho naught is equal to V by I into 2 pi S. Okay, for observation 1, we have V here. Okay, V by I is constant for all, that is 8 milliampere into 2 pi S. S is distance between two probes, that is 0.2 centimeter. Okay, then after finding rho naught for each, then after you need to find out rho naught divided by F of W by S. Rho naught we have here is divided by 5.89 is the rho resistivity. Okay, then after getting rho, you need to find out log rho base 10. Then after finding log rho base 10, you need to plot a graph as written. Plot T inverse into number 3 versus log rho base 10 of above observation in a graph sheet. See, how to plot a graph? You have to take T inverse into number 3 along x-axis and log rho base 10 along y-axis. Then after plotting the graph, you need to find the slope of the graph. Already you know slope is del y by del x, that is this part. Log rho base 10 divided by T inverse T, this part is the slope. Okay, then others you have. This is 2k, then 2.3026 10 over 3. Just multiply slope with this, we will get the result. And k values, that is also given here. Clear or not? This is all about the experiment. Then how to note the observations, I want to say, and how to write the record, I will say. Okay, see. Then first of all, aim of the experiment is over. Then go to apparatus required. Okay, for apparatus required, you have to see 02.pdf. See, here are the apparatus. See, this is the figure of the apparatus. You need to draw. Actually, these 4 are 4 probes, and the black one is the sample. That means crystal, germanium crystal. Okay, so out of these 4 probes, we are giving current to the probe. Sorry, to the crystal using outer 2 probes. See, here we are giving constant current of 8 milliampere, but we are getting voltage from the inner 2 probes. Okay, and that voltage is known as probe voltage, VH. Okay, and we are going to find out this one. Okay, this is the probe voltage. These 4 are 4 probes, and distance between 2 probes, as you always say, that is 0.2 centimeter. Okay, and you need to draw this figure, sir. See, So first of all, aim of the experiment over. Then in case of apparatus required, uh, name of the apparatus is already written. Okay, I'm showing you. Okay, these are the apparatus actually. Okay, one is that is your sample. That means germanium crystal semiconductor. Then oven of 0 to 200 degrees Celsius and constant current generator. Okay. Then digital micro voltmeter. These are the apparatus required. Okay. Then after writing the apparatus required, you have to start what theory part. Theory you have to write it from here. Okay. And in theory part you need to draw these two figures. Figure 1 and figure 2. You need to draw both. Okay, right, continue writing theory, okay, up to resistive by 4 proof, everything you must write till here, okay. Then after writing this theory part, you need to start procedure part. Okay, already procedure for simulation you have to write down. Done? Procedure for simulation you need to write down, okay. But before writing, before writing procedure, you must complete the observation part, okay. And that means these are the steps written how to perform the experiment. Then after completion of the observation part, you need to write the procedure part by changing yourself. Okay. Then after writing the procedure part, then go to observation part. In case of observation part, you have to see with 0-100 video. This is table 1. You need to write accordingly. Observation calculation. First write the constant values. Then after write table 1. Okay, note the observations. Then go table 2 for calculation of resistivity. Complete this one. Then plot a graph, attach the graph to the record, then find the slope of the graph and calculate the values of energy band gap of the given semiconductor. Okay, done. This is the plan. Okay, this is the experiment. Then right now I'm going to tell about how to perform the experiment. Okay, so after this, everything clear or not?
Yes, sir. Clear.
Yes, sir. Yes, sir.
Okay,
Yes, sir.
very easy experiment and maximum 5 minutes it will take to perform this one. Okay, so right now I'm going to simulation part. Okay.
Okay, sir.
Okay, this is the experiment. So as I told, this is a constant current generator or constant current source we are changing, and this is the digital microvoltmeter. From here we'll get the voltage in millivolt, and this is the oven, and there is a temperature sensor, and the both probe setups already inserted inside the oven. Okay, see, so first of all, range of current should be 20 milliampere. Okay, and material should be germanium. Here, silicon and germanium, but you have to select the germanium one. Okay, first select the material, then select the range of current. Okay, it should be 20 milliampere because we are going to set the current to what 8 milliampere. That's why 20 milliampere is the maximum one. Okay, you can change the current up to 20 milliampere. No need to set that 200 milliampere. So first set the current to what is the value required values? It should be 8 milliampere. Okay, as for the values given, that is 8 milliampere. Then after select cross section. Okay, no need. Then range of movement should be in multiple of 10. Okay, just select. This should be multiple of 10. Then after click set button. Okay, after clicking the set button, allow the oven for the maximum temperature, that is of 200 degrees Celsius. Okay, because we are using a oven of 0 to 200 degrees Celsius. Okay, that is written in the apparatus. See, allow it for the maximum one. Then after see how to note observations. Its and range of voltmeter should be 10 volt. Okay, no need to change it. So right now it is on 2.5. That means see how to note observations. Go to the table 1 first. Here, first observation for what temperature? 30 degrees Celsius. But it is showing what 20. Okay, so almost it is your room temperature. Okay, see after clicking on, what will happen? Okay, throughout the experiment, current should be constant at 8 milliampere. No change to current. Okay, so no need to change the current. Okay, so when current will be changed, if you change this values, current will be changed. Otherwise, no change. Okay, the current should be constant at 8 milliampere. Remember this. Then after this will give the what? This will give the temperature here, and we will get the voltage from here. Okay, then how to note observations? One is written as run. After clicking run one, what will happen? Temperature will start increasing and corresponding voltage will also change. Okay. So right now I'm going to note down the fast observation of 30 degrees Celsius. Check. Just click the run one. Okay. तो चेंज हो गया है मल्टीपल ऑफ 10 में चेंज हो गया तो यू जस्ट wait up to 30 when it is showing 30 you need to click the wait button done for 30 degrees Celsius this is the voltage in millivolt clear or not clear please reply.
Yes, sir.
Yes, sir, clear.
Okay, first observation you got. Then how to note second observation that is of 40. Once again you have to click the run one. Okay, and wait up to 40. After reaching at 40, suddenly click the wait button and note down the observation. Okay, okay. Then after once again you have to click the run. Wait up to 50. After reaching 50, click wait and note down. Okay, in this way you need to find out. At 9.5. Done for 40. This is the result. Got it or not?
Yes, sir.
In this
Yes,
way,
I got
you have,
it.
okay.
Sir.
In this way, you have to note observations up to what values? 170 degrees Celsius. Then after observation part over, then you need to convert the temperature in Kelvin mode, Kelvin by adding 273 with each. Then after you have to find out, okay, T inverse into 10 power 3. Okay. Then after rho naught, then rho, then log rho base 10, plot a graph by taking T inverse into 10 power 3 along the x-axis and log rho base 10 along y-axis. Then find the slope of the graph and put the slope in the formula of energy band graph. Then you got the result. Okay. Then after you have to write the conclusion part, discussion and acknowledgement part. Then after put your name and ID. Okay. Then make a PDF and submit it to before due date. Clear or not clear? Please reply.
Yes, sir. Yes, sir.
Yes, sir, clear.
Okay, so right now, without wasting time, okay, you just continue noting your observations. After your observation part over, just inform me. I'll take the attendance, and you need to complete everything. Okay, and submit it before due date. Clear?
Yes, sir.
Okay, I'm online. You just start noting observations. Clear?
Excuse me, sir. Sir, the
Yes.
microvoltmeter is showing the voltage in microvolts or millivolts.
No, no, no. This is in millivolt. Okay, so whatever it is showing, you just write this. Okay.
Okay,
So
sir.
this is a microvoltmeter reader. No, so this is the microvoltmeter, but you need to write this one directly. Okay, no issues.
Okay, sir.
This is millivolt. Okay. Done. Continue noting observation. No? actually you are selecting the range of voltmeter to 10 volt. That means you just see I'm changing. You just observe what's happening. If you are selecting 1 millivolt, okay, this one is rotating, but here we are getting 0 because okay, the reading is more than 1 millivolt. So always see here 10 millivolt, and you can select 100 millivolt. Okay, but here we are not get anything because we are selecting this one to 10 volt. The reading of this one is in volt, and you have to convert this one to millivolt at the time of writing. Clear or not clear? Okay,
Yes, sir.
just
Yes,
see this
sir,
one.
clear.
Right now, this is a 10 volt. Okay, so suppose you are selecting 100 millivolt. The reading is more than 100. That's why it is showing 0. Got it or not? Got my point?
Yes,
Okay,
sir.
this part I ignored.
Yes, sir.
Usually, see, okay, you have to set this accordingly. So right now, we are selecting, when you are selecting this as 10 volt means we are getting this reading in volt, and you have to convert this to millivolt. So after converting this one to millivolt, what we will get? Anyone can reply? We'll get
Excuse
what?
me, sir.
Yes, tell me.
So we are getting it in volt or in 10 volts?
This is in volt. See, once suppose you are see, actually this is the maximum. See, here also, suppose we selected what 200. That this is the maximum one. That means multimeter. We are selecting 10 volt means multimeter can make show observation up to 10 volt. More than 10 volt, we are not get anything. It will show 0. Got it? That's the maximum limit.
Yes, sir.
But this
Okay,
is
sir.
in volt only. Clear? Suppose you are
Clear.
selecting this 1 volt also, no issues. It will no change to the readings. Just see.
So,
I'm
sir,
selecting
in
1
all
volt.
the observation, the measurement is in volt only.
Yes. So right now, no option is there to for millivolt.
Yes, sir.
Because if you are changing these to 0.17982 millivolt, what we will get? What is the result? So this is in volt. If you are converting this to millivolt, what is the result? Anyone can reply?
So 0.
It should be 179.
179.
Which is
But
more than
yes,
100 millivolt. That's why we
Yes,
are
sir.
getting 0. Got it? Got my point or not?
Yes, sir.
Yes,
Yes, sir.
sir.
Yes.
yes, sir.
Okay,
Yes, sir.
that's why you have to select the max range. This what is written there? Range of voltmeter. So we are allowing the voltmeter to measure up to 10 volt. Got it? Got it or
Yes,
not?
sir.
Please reply.
Yes, sir,
So
yes,
this is the reason. Okay, that means what you are getting here, that is in volt, and you want to convert that in millivolt. Okay, no doubt. Continue noting observation. Okay,
Okay, sir.
and write. First complete the observation part, then complete the calculation part, and whatever you are getting from calculation, just write that result part. Clear? Right now I'm going to stop presentation once again.